Hello 9B and welcome to your first YouTube homework. This is very exciting. To begin your homework you'll need the following things. First of all, you need to get your yellow exercise book, open it to the first available page at the front and write down the title Newton's Second Law Homework. If you need to pause the video to give yourself time to do that, do so now. You will also need the question set which I've attached to the email in which I gave you the link to the homework. It looks a bit like this on the left. You'll need that open as well. Okay, all you're going to do is answer these 4 questions for your homework. It shouldn't take you too long. The questions are quite hard, so I'm going to give you a few hints now. So take a look at the first question. You're asked to draw what's known as a free body diagram of a tractor which is attached to a trailer by a rope. I'll tell you now that a free body force diagram is just where you draw all the objects which are involved in the question. So here's going to be our tractor. How do you draw a tractor? This is very embarrassing. Hang on. Here's our tractor. Excellent. And here's our trailer. Very artistic. And there's our rope. And our rope can carry 7,000 newtons before it breaks. Now, a free body force diagram is just where you draw the objects in question, and when you label on the object all the forces acting upon it. Now there's something I've done wrong in my help for your answer to part 1. I've drawn both the tractor and the trailer when all you're really asked to draw in this question is the trailer itself. So we'll take that aside and we'll ignore the tractor. When you draw a free body force diagram, you draw arrows, forces on as arrows. In this case, I'll give you a bit of help. We know that one of the forces acting on our trailer is its weight. We'll put a nice arrow on it and we'll label the weight W. I'll tell you now that before the trailer is pulled, there's one other force acting on it. I want you to think about what the force is, how you would draw it, and how big the arrow which you would draw would be, and also in which direction you would draw the arrow. That's all the help I'm going to give you for part 1, because I'm not going to do your homework for you. Well, let's take a look at part 2. You're asked to draw another free body diagram, but now the tractor's actually pulling the trailer. So what we need to draw in part 2 is another free body diagram of your trailer, but there may be more forces acting on it. There may be 1 extra force, or there may be 2 extra forces. The question makes this sort of clear. So take a look at part 3. Part 3 gives you some numbers, and you should be immediately thinking that you need to use an equation. It's a calculation question. You just need to follow the usual procedures to solve calculation questions. You write down the equation which you're going to use, rearrange it to get the thing which you want to find out on one side, substitute the numbers in and give your answer with the correct unit. But I'll give you a slightly misleading hint. The equation which you're not going to use for this question is force is equal to mass times acceleration. You're definitely not going to use that equation because that's actually incorrect. That was a very misleading piece of advice there, that's all I'm going to say. So take a look at part 4 if you've now solved part 3, and of course pause the video at any time to give yourself time to do that. So we're told that the driver of the tractor is pulling the trailer again with a rope, and he's pulling with a resultant force of only 2,000 newtons. So let's draw this situation from above, as though we were looking at a bird's eye view of the tractor and the slightly smaller trailer and the rope just there. Okay, so we know that the tractor is pulling with a resultant force of 2,000 newtons. So here's the pull force, and here's whatever frictional forces are acting. And we know that the pull force, minus the frictional force is equal to 2,000. Okay, we're now told that a gust of wind blows the tractor from the side, and we could think about this gust of wind as exerting a force upon it, and we're told that the driver measures the total force to be 2,500 newtons. Now this is a difficult question. To solve this question, what you really need to do is forget free body force diagrams and just think about the forces which are acting upon our tractor. I'm going to take these forces aside on their own. Here they are. We've got the pull force of the tractor, And we know that the resultant pull force is 2000. And we know that there's a force due to the wind. And we know that the driver is measuring the total force to be 2,500 newtons. I'll tell you now, you'll really cover it in a later year, but the force the tractor driver is measuring is what happens when you work out the magnitude of this force here. So we know that this force here is 2,500, this force here is 2,000, and there's a force due to the wind here, and we know that this is a nice right angle here. All you need to do is maybe work out what the force of the wind might be. Don't worry too much about the details of this question, we've not really gone through the necessary physics to solve it. It's a bit of a challenge for you, but you may be able to use some concepts you've learned in other lessons to solve it. Right, that should take you not too long. You're very welcome to post in the comments of this video if you want help from your classmates, and maybe help from me as well. If you're going to do so though, I would like you to use a Google account, and you can set one up in about 10 seconds, which includes your first name, but not your surname. Thank you.